Today we're going to look at a second example. We're going to talk about the survey we took yesterday. How many states have you visited? So we're going to use our AP Stat students as our random sample of all United States AP Stat students to estimate a 95% confidence interval for the mean number of states an AP Stat student has visited. You can follow along with this with a blank set of notes, or you can copy my completed set of notes and just follow along with my comments. I would suggest that you stop the video from time to time to actually do the work on your calculator. So here we go. Our Canvas survey revealed the following responses, thanks to those of you that responded. The number of states visited, I have 29 results here. So what I did is I put these in my calculator into list 1. Just put them in there. The order doesn't matter, but put that in there and then I can get the rest of my information from my calculator. So what type of data is this? Categorical or quantitative? Well, it's numbers, it's counts, so it is quantitative. It's going to give us the mean number of states. Quantitative value, numeric values you can take the average of, and that's what we're interested in. Categorical variables are used for our p-hat stuff we did in the last unit. So we enter the class data into list 1. We want to find the sample mean and standard deviation. We use one variable stats for that. We also want to sketch the histogram. I used a bar width of 4. There's just so many different numbers here, it gets pretty spread out if you use something different. Remember, one variable stats is under stat, calc, one variable stats. You'll put in list 1 or whatever list you used, and the frequency needs to be blank. So you may have to clear out what was there already. Hit calculate, you get your one variable stats. We don't need everything. We need X bar. I'm just going to use a few decimal places. We need the standard deviation, which we're going to use the SX for sample standard deviation. 7.688, and then our sample size is 29. Our task is to construct the 95% confidence interval to estimate the mean number of states stat students have visited. This lesson is from StatsMedic, and they follow a different procedure than our textbook authors do. Our textbook authors use think, show, tell. The StatsMedic folks use state, plan, do, and conclude as their 4 steps. So it works pretty good. Either way works, as long as you include everything that's necessary. So for state, we're going to state the parameter we want to estimate and the confidence level we're using. So what we need to say is our parameters mu, the true mean number of states visited by AP Stat students, and the confidence level is 95%. What our plan is, we have to identify the inference method and check our conditions. So the name of our procedure is a one sample t interval for a mean, and our conditions are random sample, 10% rule, and is it normal? So do we really have a random sample here? Not really. It's a convenient sample, but we will assume that it's representative of the population of AP Stat students. Our 10% condition, we want to see that our sample size is less than 10% of AP Stat students. And this is actually almost all of our Sandberg Stat students, but we want 10% of all AP Stat students, and certainly that is less than 10%. We need our data to be normal, so we're just dealing with sample data. In my histogram, which I forgot to talk about, but the histogram, it's certainly unimodal. It is kind of skewed to the right. I wouldn't consider this an outlier, but it's not extremely skewed, and it doesn't have an extreme outlier, so we're probably pretty good. If we had had at least 30 people in our survey, we would have been fine based on the central limit theorem, but that doesn't fit here. So basically, we're going to say that the sample histogram did not show strong skew or outliers. The next part is do. If the conditions are met, then we can move forward. We're going to perform the calculations. You need to write down the formulas that you're using, and then you can plug in the values for the formulas and then crank out the final answer on your calculator. The general formula for any confidence interval, and this is actually in your yellow book, is point estimate plus or minus margin of error. And that's shown here. This is page 4. Confidence interval is the statistic plus or minus critical value times standard error of statistic. That is our point estimate times the margin of error. You could actually add that to your booklet if you don't already have that. This is point estimate plus or minus margin of error. Remember, that note's not going to be there for your AP test, but you can use it in this class for practice. Okay, so the point estimate is x bar plus or minus the margin of error for an inference on means is our t critical value based on some degrees of freedom times the standard deviation of our sample divided by square root of n. In our case, to get the t critical value, move this over a little bit. We're going to use table B, which is on page 10. We need degrees of freedom. Remember, degrees of freedom is n minus 1. So in this case, it's 28. So we'll go to page 10, which is our table B. We need 28 degrees of freedom at 95% confidence. So 95% confidence has 0.025 in each tail. You can also use the very bottom row to find 95% confidence. And I'm going to go up to degrees of freedom of 28, and I get 2.048. 2.048. The other way you could get t star, or t critical value, is from inverse t, which I talked about yesterday. So our confidence interval is going to be x bar, which is 18.034 from up above, plus or minus 2.048, our t critical value. Our standard deviation for our sample was 7.688, and our sample size was 29. Be careful here not to divide by square root of 28 instead of 29. That's an error that sometimes students will make. Anyway, if we crank out the margin of error, we get a margin of error of 2.924. We're going to add and subtract that from our point estimate, and I get a confidence interval of about 15.1 to about 21. We conclude that by writing out our nice sentence that includes context. We are 95% confident that the interval from 15.1 to 21.0 captures the true mean number of states an AP Stat student has visited. Remember, we're trying to find the mean, the true mean for the population. Okay, so what do we have here? Let's conclude the parts. So on the next page, we have a box for important ideas. We want to use a 4-step process. State what you're trying to find, which is going to be the parameter mu, our true mean. Plan it out. What test are we running? It's not a test. What are we trying to do here? A 1 sample t interval for the mean. Name the test. The conditions, randomness, 10%, and normal. Remember, for the normal, we either know that the population is normal, or we know that the sample size is big enough and fits the central limit theorem, or we know the sample shows no strong skew or outliers, and we're going to graph it to show that. Our mechanics, we're going to do our confidence interval, which is x bar plus or minus t star times s sub x over square root of n. That's supposed to be t star. Kind of messed it up. And then we conclude, make a statement that includes the confidence interval and the confidence level and language that indicates you know it's about the mean value. Okay, so it kind of concludes it. The next problem I want to go over is a problem that shows an example of how to find the sample size given a margin of error. So this is a good problem. You might want to stop the video and read it real quick. But basically what we want to do is see how much time students are spending on homework on average in a typical week. We want a 90% confidence interval with a margin of error of 30 minutes. Pilot study indicated a standard deviation is about 154 minutes. How many students do we need to use to meet the goal to estimate a margin of error at most 30 minutes? So our margin of error, remember, is t star times standard deviation over square root of n. But we can't get t critical value, or t star, unless we know what n is. We're trying to find n. So since we don't know n, we don't know the degrees of freedom, so we're going to use z star instead. And remember, z star, or actually if we look at the page 10, the table B, t values, if you look at the very bottom of this table, it shows infinite number of degrees of freedom. That basically is the normal model. So the very last line shows your z star scores. I'm going to actually add that to my table to show that the last line is z star. So a 95% confidence level, the z score would be 1.96. Maybe you have that memorized already. Whoop, not 1.96, sorry, wait a minute. This is a 90% confidence level. I knew that one, right? 1.645 is what we want to use. 1.645. So our margin of error is 30 equals z star 1.645 times my standard deviation 154 divided by square root of n. It's n that I'm trying to find here. I solve this equation for square root of n just by rearranging the rest of the numbers. I'm going to square both sides of this equation and then plug all that into my calculator. I get n equals 71.31. Always round up here because you want to be more conservative on this, and I'm going to say 72 students are required. Hey, if we think back, 72 students, that would have satisfied the central limit theorem anyway, and we could use a normal model with a z-score anyway. Okay, that's all I'm going to run through for today. I would like for you to try problem number 2, and on my notes sheet on Canvas, you can take a look at the answer. Have a great day.